Hello and welcome. In this particular video, we're going to use a skill that I'm seeing quite commonly in HSC questions, okay? It's not part of the year 11 syllabus, so I think we need to just cover this in like a little bit of detail so you can answer questions like the one below. Essentially, it's basically solving quadratic inequalities. So you've already learned how to solve inequalities that look like, something like this. Being less than or equal to 0, or 2x plus 5 being greater than 0. Those are called linear inequalities. It's a little bit different when we get to quadratic inequalities. I'm going to show you where they pop up and why we have to look at them very, very carefully, because they aren't solved in the exact same manner as linear inequalities. Okay, so let's have a look at the 2021 question. That's a band 4. It's worth 3 marks, and it basically says for all values of x is f of x equal to x squared minus 2x cubed increasing. Okay, so I'm going to answer this question up until a point. I'm going to show you where we get stuck without actually having a technique to sort of help us. So where we want to find where a curve is increasing, all right, we want to check essentially where the first derivative is greater than 0, because that's where all of our gradients are going to be positive. Okay, so we end up with our curve sort of going up, right? Meaning that it's increasing, okay? All right, so the first thing that we're going to do is we're going to differentiate. So f dash of x, okay? Differentiating x squared, we end up with 2x, and differentiating 2x cubed, we end up with 6x squared. Now what we're going to do is we're going to let our first derivative, okay, be greater than 0 to find where f of x is increasing. Okay, so we now have this thing. So 2x minus 6x squared, I'll just fix this x up, being greater than 0. If it's equal to 0, we end up with a stationary point. Okay, now this is a quadratic equation. All right, and so factorize it a little bit. I'm going to have a common factor of 2x out the front of 1 minus 3x is greater than 0. And you'll notice that we actually run into a little bit of an issue here. Okay, because we actually don't have a technique available to us at the moment to try and solve this. Okay, so what we're going to do is we're actually going to come back to this point after I've shown you the technique of how to solve it. All right, just so you can see right at the very end why this skill is important and where it comes in. It's not just only in this context, but this is sort of to help you out in a variety of contexts, mainly in the area of curve sketching. Okay, all right. So let's have a little bit of a look at this particular question. Okay, all right. Find the domain over which y equals x cubed plus 12x squared plus 45x minus 30 is increasing. Okay, so this is a relatively straightforward question, okay? All right, so to find where our original function is increasing, all right, we need to first find the first derivative, okay? So in this particular case, y dash is equal to differentiating this curve over here. Differentiating x cubed, we get 3x squared. Differentiating 12x squared, we end up with 24x. Differentiating 45x, we end up with just 45. And differentiating 30, negative 30 actually, because it's a constant, we end up with 0. So it just disappears in regards to this particular thing. Now, remember, our y is increasing when our first derivative, that function that we've just found above, okay, is greater than 0. Okay, so now what we're going to do, all right, is we're going to dive into solving a quadratic essentially, okay? All right, so we're going to treat it exactly like a quadratic. We're going to go through the method of factorizing it, okay, which you should be okay with by this point in your mathematical career. If you're not, I'll show you the steps anyway, okay? So therefore, it's increasing when 3x squared plus 24x plus 45 is greater than 0. Now, you'll notice that each of these have a common factor of 3, so I'm going to divide everything in the entire equation as well through by 3. So dividing the first by 3, I get x squared. Dividing 24 by 3, I get 8x. Dividing 45 by 3, I get 15. All right, and then dividing the right-hand side by 3, I end up with 0 still, which is really, really nice for us. Okay, all right. Now that just makes it a much, much easier for us to go and factorize a monic quadratic, okay? Now, you've probably seen different methods before. I use a method called PSF, product sum factor, all right? And essentially we're looking for two numbers that multiply together to give you 15, all right, and add together to give you 8. So product, sum, and the factors. So the product is 15, multiply. The sum is 8, add. All right, the two numbers that are going to add together to give us that are 5 and 3. Okay, so 5 times 3 will give you 15, and then 5 plus 3 will give you 8. And because it's a monic quadratic, we can just jump straight into the factorized form of x plus 5 and x plus 3. If you're not quite sure how to do that, I do have another video on how to actually factorize quadratics in my year 10 playlist, all right, if you're a little bit stuck on that, okay? So now you'll notice we're back at the same point as what we were before, all right? We're back here with this quadratic being factorized and an inequality. So what do we do? Okay, well, the first thing to recognize is that this is a quadratic, and a quadratic, when we graph them, is just a parabola. Okay, so somewhere on your page, preferably near your question, all right, I encourage you to draw a small Cartesian plane. This doesn't have to be neat, it just has to get the point across. All right, so what I need you to do is just to imagine you are going to graph the parabola y equals x plus 5 and x minus 3 on that Cartesian plane. All right, you would know that the x-intercepts are going to be the opposite of plus 5 and the opposite of, and the opposite of plus 3, which is negative 5 and negative 3. Those are going to be the x-intercepts of that parabola. And the other thing to remember is when you look at the x's and you multiply them together, they would be positive. So the parabola would be concave up. Or a much simpler way to understand that is a happy face. Okay, again, I'll just fix that up. It doesn't have to be neat, just has to sort of get the point across. All right, when you're sort of drawing this, there is our parabola. Now, let's actually unpack the question and see what it's saying. You'll notice this little bit here asks where it's greater than 0. Okay, well, this line here is where your parabola would be equal to 0, the x-axis. So what it's actually asking you to do is for what x values is your parabola greater than 0? Well, it's greater than 0 for anything that way and for anything that way. All right, so anything on the right side of negative 3 and anything on the left side of negative 5. All right, just highlighting that out because you'll notice you're looking for a greater than 0, meaning where is it above the x-axis? Okay, and what we're doing here is essentially that allows us to sort of test the regions where this inequality is going to be true. All right, so to answer this inequality, anything that's bigger than negative 3, all right, so we say anything that is bigger than negative 3, and anything that is smaller than negative 5, so anything that is smaller than negative 5, will solve this inequality here, okay? And you can check that just by substituting in any values you want, okay? All right, so the long and the short of it is you'll notice that we're just checking where the parabola is just above the x-axis because of that. If it was less than 0, we'd check where the parabola is below the x-axis if we wanted to, but we're not doing that in this particular case. All right, so this is a solution for your quadratic inequality, okay? Those two values. Now, before I move on, something to help you out in regards to this particular question, notice that the arrows are pointing in different directions. And notice that the region that we're talking about on our parabola is not together. They are split up. So if your highlighted region that we're talking about, all right, is not together and it is instead split up, all right, the arrows will point in different directions for your inequality. That's just something to sort of help you sort of remember if you're not 100% sure on your answer, okay? All right, so let's have a little bit of a look at another one. So moving down, all right, to our next question. We're asked for what values of x is f of x decreasing, all right? Now we have another cubic here, all right? You imagine when you have a cubic, all right, it sort of looks like this style of curve usually. So you can have multiple areas where your curve is decreasing and multiple areas where your curve is increasing, all right? In this particular one, if you look at the cubic, that area there is where it's decreasing, okay? All right. So the same process, we differentiate, all right, we find where it's decreasing, and then we solve the process of the quadratic inequality, okay? All right, so differentiating, okay, f dash of x is equal to, all right, differentiating x cubed on 3, all right, the multiplication by 3 will disappear and we'll end up just with x squared. Differentiating minus 4x will give us minus 4, and differentiating plus 2 will just give us 0 because the derivative of a constant is 0. Now, if you're stuck on where the 3 disappeared to, when we differentiate x cubed on 3, this happens. We bring the power down, subtract 1 from the power, and then the constants on the top and the bottom will cancel. That's why that thing particularly occurs. All right. The next thing to unpack is just having a little bit of a look here. It asks where our curve is decreasing. Well, remember, when our first derivative is less than 0, our curve is decreasing. Okay, so it's the opposite of the example that we've done before in this particular case. Okay, all right. So we're going to have our x squared minus 4 being less than 0. Again, you go through the process of factorizing. This is a difference of 2 squares. All right, so x minus 2, x plus 2 being less than 0. All right. Now, once you get to this step here where you have that fully factorized quadratic equation, this is where you now go away and you draw off to the side somewhere a nice, neat little picture of your parabola that we're drawing here. So have a look at the intercepts. So the opposite of the one in here will be plus 2, okay, because we're finding x-intercepts now. All right, ignoring this inequality sign, we don't worry about that. So the opposite of here is plus 2, and the opposite there is negative 2. So at positive 2 and at negative 2 will be our x-intercepts of our parabola. And we know that our parabola, okay, if we look here, we can see it's positive, but if we multiply all of the x's together, we can also see that it'll be positive. So it is concave up, all right, meaning that we have a happy parabola. Let me just try and fix that up a little bit. Again, this diagram over here doesn't have to be exact. It's purely just to help you test your regions, okay? So let me break this down again, all right? We've just found the x-intercepts for this parabola, all right? Now we're going to check where it is below the x-axis instead of above. Notice that we said up here in this particular example, above the x-axis, all right, because it was greater than 0. Because it says below, less than 0, we're going to check for this region below the x-axis, okay? All right, so I'm just going to highlight where my parabola is below the x-axis, and that's this green section here, all right? So have a little bit of a look here. I might sort of highlight this in red. For everything that's bigger than negative 2 and really highlight onto my words there, and less than positive 2, all right, our parabola is below the x-axis, okay? All right, so let's put that mathematically, all right? So everything, let me just fix that up. Everything where x is bigger than negative 2 and less than positive 2, right, means that our x values are sort of sandwiched between the two, all right? So it should look a little bit like this. To sandwich them between the two, we have to say that our negative 2 is our less than our x, and on top of this, our positive 2 is also greater than our x. So we end up with that inequality statement there, okay? Now, something that's worthwhile, whether this curve was above the axes or below the axes whenever we're doing this, it doesn't matter, okay? This is just sort of to help you remember, okay? Up here, our two sections were split from each other and the arrows pointed in different directions. Notice here that the bottom part of our curve is connected throughout the region that we care about, and our arrows point in the same direction, okay? All right, this is what it means when our graph looks like this. So just taking you through the steps. First step, differentiate. Second step, all right, set it to whether it is decreasing or increasing. Third step, factorize. Fourth, draw your parabola. And fifth, determine your inequality. Okay, so now we can actually go ahead and we can actually finish. I'll do this in purple. We can actually finish our answer above now that we sort of have that skill. All right, so we're at this point. So now what we need to do is we need to draw the parabola that's sort of associated with it. There are other methods of doing this. I'm just a visual person and I like to see the pictures when I draw them. All right, so drawing my little parabola over here, we know that for this, we will have a x-intercept of being 0. And then when we go to solve this bracket, again, using that null factor theorem, all right, just think about how we would have solved that. That would end up being, over here, I'll show you, 1 minus 3x being equal to 0. Add 3x to the other side and divide by 3, x equals 1 over 3. So we have this intercept of being 1/3. Then the only other thing that we have to do is we just have to check whether or not it is a happy or a sad parabola. All right, so have a little bit of a look here. You'll notice that our highest power of x is negative 6x, is a negative number, right? So it's a negative. So it's actually a sad parabola. So when we go to draw it, it looks like this. All right, you'll notice that it sort of points down. All right, now we're nearly there. We're almost to the answer. We've drawn our parabola. Our next step is to find the region. It's greater than 0. All right, well, that's where our parabola is above the x-axis. All right, so using that trick that I taught you, and we'll do this in purple, all right, we're talking about this region in here between 0 and 1 over 3. So everything bigger than 0 and everything being less than 1 over 3. All right, has to satisfy both of those two conditions. Or you could just remember the line is connected, so everything must point in the same direction. So our x has to be in the middle, and our 1 over 3 has to be here, all right? And we just point them in such a way that all of the arrows point from the biggest number down to the smallest number, all right? So the solution for where our values of x, that f of x is increasing, all right, is between 0 and 1 over 3. That's where our original curve is increasing. Okay. All right. So same thing here. Our original curve here is increasing for x being less than -5 and being greater than -3. All right. And then the same thing down here in between -2 and 2 is where this original curve is decreasing for that particular one. Okay, so it's the same steps over and over and over again. You can see where the 3 marks come from, usually around, in the case of our recognizing that we're differentiating and setting it greater than 0. Then here, all right, this next mark of factorizing and getting up to this point. And then here, all right, your third mark for testing your regions using your derivative graph. Okay, all right, I hope you found this useful. Okay, that's how you solve quadratic inequalities. They pop up in a variety of places within inside of calculus, and I hope you found that useful. Thank you.